Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the question and answer window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions. Your questions in the question and answer window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Khaled Merzik, Senior Marketing Manager, Process Chromatography at Bio-Rad.
Thank you for taking the time and attending our presentation. And I would like to just start and go ahead to present the webinar. Today's presentation is about the CHT Prepacked process scale columns, for GMP manufacturing. And this is a new product that introduced by Bio-Rad. When I say the new product, I'm referring here to the prepacked columns. Bio-Rad has been, Bio-Rad owns the CHT product line and the trademark for many years. The product is available and was available for a long time and still and will be available for our customer. But we took this more to go into the next level, which is having the columns in a pre-packed formats. Today I'll talk about introducing the product. After that, I'll cover this product specification and packing quality and the cycling data as well for a pre-packed column. And then talk briefly about the performance in terms of pressure flow data as scale-up data example, and then we'll go with to answer some of the questions at the end of that. So the pre-pack column, basically what Bio-Rad is introducing here is in a form of diameters 5 to 33 centimeters with two-bed heights option, a 10 or 20 centimeter. These are columns going to be a GMP ready. They come back. They are packed, tested, packaged, and qualified to be a GMP ready. And these columns are a Bio-Rad product and Bio-Rad trade name, product name, and basically they come from one source. When we say one source here, that means your resin manufacturer and supplier is your pre-packed column supplier as well. And that's typically what it means in terms of technical, support, technical need, procurement need, and all that. They all come from one source, which is the resin supplier directly to you. These are the different diameters that covers in the pre-packed columns from Bio-Rad, particularly, starting with a 5 centimeter and all the way to a 33 centimeter with the two-bed height options. The column at the far right, displays the volumes of each of these columns. The one thing about the design of these columns is standardized. The hardware design is standardized as well as also has an IP for Bio-Rad. Bio-Rad has already an IP that's submitted for registration for this column design that actually allow us to maximize the packing process as well as allowing us to be able to ship these columns from one point to another point around the world. And what that means, the scalability of these columns, and we'll see in some examples of data later, will also, based on the current design, is optimized to meet the this required specification for these products. This is just a kind of a photo showed of the different type of columns. As I said, these columns start from 5 centimeter all the way to 33 centimeter diameters. The Foresight Pro column is a complementary of the existing sampling tools that typically used for screening tools, the Foresight columns that 96 well plate or robo column or a 1 or 5 milliliter columns. The column design, the hardware design, as I talked briefly earlier, this column hardware design is designed and also has based on a standardized design as well as on a patented technology for Bio-Rad that allow us to be able to efficiently pack the column. And as we all were aware that, for CHT users particularly, they were aware that CHT is called non-compressible resin. Therefore, this design allow us to be able to pack the column but not compress the resin, which means the column bed will will be stable and also well maintained during the shipping. The plus and minus on the bed height is around 1 centimeter. So 20, it could be somewhere around slightly above 20, but it is going to be stable, during the shipping until it gets to the point of the end user, but still will maintain its stability. The specifications of the column hardwares are, optimized to meet the place per meter above 4,800 place per meter, and the asymmetry in the column is between 0.8 and 2.2. And these are GMP ready columns, so there is also a bioburden, microbial bioburden data as well as the endotoxins. These are GMP ready, so there will be a regulated supported file for these columns. And there's also additional documents that's typically used by the end user or needed by the end user. Each of these columns comes with a buffer reservoir, and those buffer reservoir has the storage solution that's used for this. These columns are stored in 0.1 normal, sodium hydroxide, and the GMP columns, as you'd expect, they have a specific requirement for the material of constructions. This table basically summarize those requirements and what regulations they meet for that. I would just point that the 5 centimeters is the only exception in terms of the tube used in this column, and it is based on a glass tube. Okay, so we'll talk about the packing quality here, and mostly we'll focus on the plates per meter as well as the asymmetry factor. These columns, as you would expect, you pack the column, you optimize the packing, and then the packaging, and then this column will be sent, shipped. So you would expect we have done thorough testing to ensure that the packing and packaging will work for these different shipping conditions. And that's exactly what we did. There is a standardized ISTA 2A shipping test that's basically that simulate different shipping situations that for these products. Not only that, what we did actually ship these columns to different collaborators around the world, as well as to different Bio-Rad sites, and we evaluated the column before and after shipping. So the data you will see next will represent what is before shipping and after shipping. So what you see here particularly is the representation of the plates per meter. What you see if you see the first column, which is the 8 centimeter 8 by 20, the left side of it, it's the one before shipping, and the right side after shipping. What it means is we pack the column, and then we test the column and establish the asymmetry and HETP, which is a plate per meter. After, that's what we call pre, and then after that we ship the column to a testing facility or to a testing lab of a Bio-Rad or a collaborator. If we ship it, and we started this, we ship these to a testing facility that conduct the ISTA 2A test. And I just want to point that the ISTA 2 tests are different levels. 1A is the basic level, 2A is the more aggressive, and then the 3A does additional testing. Bio-Rad actually conducted on an external facility testing using a 2A standards, but we also have an internal testing facility that did the 3A part on this one. So the data here represent scaled different diameters to ensure that actually, when you change the diameter of the column, there's a different bed support. But as you can see, this data shows minimum change, which actually represent that these columns are well packed, well designed, and well packed and well packaged to allow us to be able to, send them around the world to the end user, as well as the end user move them from one place to another. The asymmetry data is, again, you can see the data here before and after, and you can see in this particular case that the change is very minimum and well within the specs for the expected performance. And then I would, okay, so this is basically, summary of first, the column maintain the performance post-shipping as you would expect for a pre-packed column. Okay, cycling data here. I just want to briefly, mention that when we talk about cycling, it is when you put a flow of buffers through the column. You would expect the column to withstand the flow conditions. So what we did here is we cycle the column for 10 cycles. And what it means here, we used a buffer. I just want to point out that this data we're showing does not have a feed, but we do have additional data that does have the feed in it. And the data here, and the one with feed actually is done by collaborators. And as our data here shows that cycle one, and when cycle one, basically what it means is when we pack the column and run the buffer system in it, we record the asymmetry and we record the place per meter. And then we do a cycle 5 and 10, but we're displaying the data of cycle 1 and cycle 10. As also you would expect, the performance does not change in this case. This data represent both columns, both asymmetry and blades counts. And as you can see, across the different diameters of the column, there is no change in terms of the performance. Okay, the third data here we have is representing the pressure flow data. And the pressure flow data basically, CHT has a property that displays a linear pressure performance. And it's a predictable that you have a certain flow rate, it's linear performance. So at 3 or 4 times that flow rate, you probably would expect around 3 or 4 times that original pressure you measured. The data here represent the pressure across the column, and I want to say that this data was done on an 8 centimeter, but we do have data that's for a larger column as well. So you would expect the column to work well and stay stable when you cycle the column, but as also when you subject to the column to different flow rates conditions. So we basically rate these columns as less than 3 bar at 250 centimeter. In this particular, we use a phosphate buffer. Okay. The scale-up data, you would expect the column to linearly scale. And that's when I talked earlier about the standardized design, what basically it means for us is we design the column, we design the packing methods for these columns in a way to ensure that when you use a 5 centimeter and you go for a 33, you would expect the performance of the column to be maintained. It maintains the separation power. It maintains the all the elements of that, whether it's the separation or it's the asymmetry of the peak. This is an example representation of that data. We actually have other data for the bigger columns as well, but we just took this as an example representation of that particular, experimental condition. We expect these columns to address. The beauty of this and using these kind of columns basically is actually minimize the worry on the end user side if this of the performance is well maintained when you scale the column. As this is what you would see here, the performance is maintained, and at least the kind of the work needed sometimes to repack a column to make sure the performance is well maintained is taking off the mind of the end user. And then I want to conclude with a summary here. These columns come basically already shown. They have a performance that an excellent performance expected, from a CHT and then expected from a CHT in a pre-packed column. The data presented has a quality data that include asymmetry and HETP. There's endotoxin and bioburden testing done on these columns. These columns come packaged as well, and bagged for the GMP end user. The columns maintain performance after shipping, which is, I think, one of the most critical things. The columns forms no headspace within the testing flow rates and pressure conditions. These columns are regulated. They come supported with regard to support file. That is for the end user, for a GMB expected from a GMB, product. All weighted parts meets the requirements. All columns backed in an ISO class 7 clean room. And I want to mention also that each column comes with a tall or a tag sample that has the same lot and not like a blended from a different lots. Few things to mention here. This is a resin manufactured column. That's you would expect this column to be high quality, which is they are. When we pack each column packed from the same resin, so there's no blending at the packing side between different lots of resin for the CHT. The other thing is, as I mentioned earlier, these are supplied by the column supplier, which you expect that this is a very smooth process to you expect from the resin supplier to address especially supply chain issues, lead time issues, and all that. And it also provides you a single point of supporting your need for the column, which you would expect when you order from a resin supplier as well. I think that's it for me, and I'll thank you so much for taking the time and attending, and I'll turn it back to you.
Okay, great. Thanks, Khalid. So, the first question is there a benefit to using GMP ready instead of non-GMP column during tech transfer or scale up?
Yeah, the major benefit in some cases, the non-GMP does use a different class of material. We usually say here, as I pointed in the summary and as I shared in data, that all weighted parts meet certain requirements, but a non-GMP sometimes may not have all these parts. And in these situations, basically, when you test a GMP ready, you have actually minimized all the different potential issues that come from using non-GMP weighted parts. And we talked with a lot of end users, and they pointed to those benefits. What they say, they usually like to go straight to use a GMP column when they transfer the process and doing the engineering runs.
And what is the typical lead time for ordering the prepacked CHT columns?
Um, we all, aware of supply chain issues here, but we're not using this as an excuse. So currently, we have actually columns in inventory, but I would say expected lead times, it should be less than 8 weeks at maximum.
Okay. And it looks like we have time for just one more question for the webcast. If we didn't get to your question, we are going to be passing those on to Khaled and Mark's team, and someone will be getting back to you. Um, so the last question for the webcast is, what is the shelf life of these columns?
So the shelf life is 2 years for these columns, and we typically tell end users, we maintain backup columns for you, and the lead time is so short that you may not need to store them at your warehouse. Typically, this shelf life, 2 years, is based on a real, shelf life data, as well as, on what we call accelerated shelf life data. And what it means in this case is we tested these columns, we compared the performance of these columns on a certain time, scale, progressing with the study, and the data basically maintain the performance of these columns, and expected to be for as expected in the Bio-Rad shelf life, for these columns, which is 2 years.
Well, thank you so much, Khaled, for stepping in, and thanks to our audience for joining us. The recorded version of this webcast will be made available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future Bioprocess International Ask the Expert webcasts. Look for those announcements in your inbox. Goodbye.
Thank you.